Section 4.3, angle side angle and angle angle side triangle congruence. Postulate 4.3 states that if two angles and the included side of one triangle are congruent to two angles in the included side of another triangle, then the two triangles are congruent. So here we have angle A and angle D are congruent, side AC and DF are congruent, and then angle C is congruent to angle F. So we end up with angle, side, angle congruence. Which two triangles are congruent by angle, side, angle? Explain. So remember, we're looking for two angles and the included side between them. Well, here we have H is congruent to N, G is congruent to I, but the side NF is not between the two angles, so this guy is out. And then if we look at the first and the last angle, or triangles here, we have the angles with the side in between, so the included side is included. So right now, because we know that angle G is congruent to angle C, and that HG is congruent to CA, and that angle H is congruent to angle A, that we can then state that these two triangles, in this case triangle GHO, is congruent to triangle CAT by angle, side, angle. Which two triangles are congruent and congruent by angle, side, angle? Explain. So once again, we're looking for two triangles that have congruent angle pairs and the included side congruent as well. Notice here that this triangle does not have its included side as the marker as congruent, so this one's out. So our two angles, or two triangles in this case, that are congruent are these two here. So that means we have triangle UVS is congruent to triangle EON by angle, side, angle. All right, we got a proof here. In this proof, they tell us, or we're given, that C is the midpoint of BE and angle B is congruent to angle E. So we're going to start this proof with the given. So C is the midpoint of BE and B is congruent to E. We'll also mark our diagram with the information provided so that way we can see where our congruence lies. The second step of this proof, we want to identify our keyword here, midpoint, and we kind of want to apply whatever that means. So if C is the midpoint of BE, that means that BC should be congruent to CE because the midpoint's creating two congruent segments. So step 2, let's say that BC is congruent to CE by definition of midpoint. Right now I have an angle, a pair of angles, and a pair of sides. I can find one more pair of angles by looking at vertical angles here. In this case, ECD and BCA. So my next step is I'm going to talk about the vertical angles. So BCA is congruent to ECD by BAT. So now if I look carefully at this proof, I've got angle, side, angle, which is enough to prove that triangle ABC is congruent to DEC by angle, side, angle, triangle congruence. Second proof, CAB is congruent to DAE, BA is congruent to EA, and B and E are right angles. Keep in mind, right angles mean they both are 90 degrees. So we'll start off with our given, and this is a long given statement, but we'll try to fit as much of it in here as we can. So angle CAB is congruent to DAE, BA is congruent to EA, and B and E are both right angles. Given. Well, remember, to be right angles, they both have to be 90. And so we know that they're congruent because they're both 90, so we can state that in the next step. B and E are congruent by definition of right angles. So now showing that those angles are congruent, I've now got angle, side, angle, and angle, side, angle. So that's enough to show triangle congruence. So in this case, ABC is congruent to... there's a typo. So ABC is congruent to... Let's go with, change the word, AED. And this time, it's by angle, side, angle congruence. Postulate 4, or Theorem 4.2, Theorem 4.2, angle, side theorem, states that if two angles and the non-included side of one triangle are congruent to two angles in the corresponding non-included side of another triangle, then the triangles are congruent. So this time we're looking for two triangles that do not have the included side, but they have to have the corresponding non-included side. So here we've got A is congruent to D, angle B is congruent to angle E, and then AC is congruent to DF. Notice that angle B is directly across from the side they include, and then the angle in which angle B is congruent to, E in this case, is across from the side that is congruent to the other triangle. The location of the sides matter. So since this is our double angle, the side that's congruent here is across from it, so it has to match up. This has to be your double angle, and the side would have to be there. So that's what they mean by corresponding. They have to be in the same location within the two triangles. They just cannot be the included or in between side. So proof here. Angle A is congruent to angle D, angle B is congruent to angle E, and AC is congruent to DF. Prove that ABC is congruent to DEF. Well, first step of this proof, we're going to restate part of the given. Second step, we're going to keep stating the given. And then third step, let's state the last bit of the given. In this particular proof, they happen to have given us all of the information we need here in the given. We have angle, angle, and then non-included side. Angle, angle, and corresponding non-included side. So that's all we need to prove that these two triangles are congruent. So ABC is congruent to DEF by angle, angle, side, triangle congruence. Let's try a proof that's a little more difficult. That one's a little too easy. So here, PR is congruent to SR, and angle A is congruent to angle I. That's our given statement. And we're asked to prove that triangle PAR is congruent to triangle SUR. So we start off by stating the first part of our given. And in reality, you can state both parts of the given on the same line if you want. Here, I'm just breaking it apart to make it nicer. I'll state the second half of the given. And then from there, I know that I need one more piece of information. Well, right now I have an angle and I have a side, but I probably need another angle. Well, the only way I'm going to find that angle is to look and find vertical angles here. So I'm going to recognize that I have vertical angles in this triangle, which means I can then state that angle PRA is congruent to SRI by vertical angle theorem, or VAT. Now that I've proven that, I now have enough information to use angle, angle, side, triangle congruence, so I can state that triangle PAR is congruent to triangle SUR by angle, angle, side, triangle congruence. All right, let's try another proof, but this time even more difficult than the last. This time we're given that angle M is congruent to angle K, and WM is parallel to RK. We want to prove that triangle WMR is congruent to triangle RKW. All right, so the first thing we need to do, state that given statement as our first step. From there, look at the fact that they gave us parallel lines. Previously, I stated parallel lines are a good indicator of the use of alternate interior angles in proofs. This is going to be no different. So if MW and RK are parallel lines, we can treat this line as our transversal, which means we are able to create congruent So we're able to create alternate interior angles here and here, which means we're able to say that angle MWR is congruent to KRW by alternate interior angles theorem, or AIA. The next step we should notice is we've got two pairs of angles, but now we probably need a side. Well, the green line I've highlighted is a common side amongst the two triangles. In this case, we should recognize that RW should be congruent to itself through the reflexive property, because RW is a part of both triangles. So we can say RW is congruent to RW through the reflexive property. And this gives us the side we need. So now we have enough information to show angle, side congruence between the two triangles. So our last step of our proof is going to be to state that triangle WMR is congruent to triangle RWK through angle, side triangle congruence. Which postulate or theorem could you use to prove triangle ABC is congruent to DEF? Well, in the first example, we've got clear markings of angle, side, angle, and angle, side, angle. So we would say angle, side, angle, triangle congruence. In the second example here, we've got angle, side, because that's the non-included side, and the same thing holds up for the other triangle, so we would use angle, side congruence here. In triangle RST, which side is included between angles R and S? Well, if we wanted to here, we could just graph a quick diagram of what a triangle RST might look like. RST, and the side included between the two would be this side here. So that would be RS. In triangle NOM, NO is included between which two angles? Same thing could happen here. We'll just draw a nondescript triangle, NOM. The angles that it falls between would be angle N and angle O. And then the last question, suppose angle E is congruent to I and FE is congruent to GI. What else must you know in order to prove that FDE is congruent to GHI by angle, side, angle, or by angle, side? So the easiest way to set this problem up is let's just go ahead and try drawing two triangles, one for triangle FDE and one for GHI. So we've got FDE and we've got GHI. So right now we know that I and E are congruent. Tells us in the problem. FE is congruent to GI. And so what else do we need to know for angle, side, angle? Well, for angle, side, angle, we would also need to know that angle F is congruent to angle G. For angle, side, we would need to know that angle D is congruent to angle H.